The topic of today is about the blood types and how we can proceed if the patient needs a transfusion, a blood transfusion. Now, the first topic that we have to cover is about the different types of blood that we can have in our planet, basically. And this one is a topic that was not really far away discovered, because during the World War I, for example, the patients or the soldiers died when they received a specific blood type, and another one survived. So they tried to investigate a little bit more what was happening, and they find out the different blood type we have in our human being. That one is the brief summarize about the blood type, and I encourage everybody to read in more details in your textbook. However, in our erythrocytes, we mark any erythrocyte with a specific antigen. An antigen, most of the antigen is a type of protein. So during the time of development and before birth, the baby develops the blood type. Now, according with the type of antigen that they mark the erythrocyte, we found different blood types. That is A, B, AB, or O. What is the difference between any of those? Is the type of antigen they have in the surface of the erythrocytes. So this individual develop antigen A in all the erythrocytes they have in their body. The type B has antigen B. The AB has two types of antigen, antigen A and antigen B. And the type O doesn't have any type of antigen in the surface. The other concept that we have to understand is the type of antibodies the different types develop in their plasma. So in the type A, where they have antigen A, they develop in plasma one type of antibody that is anti-B antibodies. In other words, if we want to transfuse B blood into A blood, something is not matching, but I explain later on. In the type B, where the patient has antigen B, this patient develop in plasma anti-A antibody. In the type AB, the patient develop antigen A and antigen B in the surface. But in plasma, this patient doesn't develop any type of antibody. The last type, that is O, the erythrocytes in this patient doesn't have any kind of antibody, any kind of antigen, but this patient develops in plasma antibody A and antibody A antibody in their plasma. Now, I will leave this size of the whiteboard for the next explanation. Now, what is important is to understand how the interaction happened in a transfusion. Now, keep in mind this concept, and I took the time to match the type of antigen with the color and with the corresponding antibody in plasma. So in other words, the anti-A antibody has a shape that potentially can match with their antigen. So if I have antigen A that is transfused from the donor, can eventually conjugate or connect with this antibody. Now, let's go to the real scenario. I wrote on the top over here a statement that my students need to keep in mind at the time to study. And it's a very important statement that I think will help you tremendously. Because what happened in a transfusion is that the antigens of the donor connect or interact or conjugate or match with the antibodies of the recipient. And in this case, eventually can cause agglutination or mismatch. If the blood type that we transfuse from the donor into the recipient doesn't have the requirements to be safe, this transfusion can cause mismatch or agglutination of the blood we transfuse in the recipient. If this one is the case, agglutination or mismatch depends with the amount of blood we transfuse. But eventually, this transfusion is not safe, could be not safe, and the patient can die. And this one is what happened before the blood types were discovered. Now, in this scenario, in the last scenario, I took the time to make one scenario where the recipient is blood type AB. Blood type AB has antigen A and antigen B. But this blood type doesn't have non-antibodies developed in plasma. Now, if this one is the recipient, I'm going to use as a donor a type O. And type O doesn't have any antigen in the surface and has this type of antibodies in plasma. Now, based on the previous statement, when I mentioned that the conjugation or the connection is made by the antigens, I want to have my brown marker. In this scenario, the donor doesn't have antigens and this recipient doesn't have antibodies. Now, pay attention about these statements. Antigens in the donor on the donor's blood type surface connect with antibodies of the recipient. Antibodies of the recipient. So right here we don't have none, zero antigens. And in this plasma of the recipient, I have no antibodies. Is it possible to conjugate or connect these no antigens with no antibodies? It's not possible. That's why O can be transfused safely into B. So this one is, yes, is safe transfusion. Now, with the same concept, let's pretend that the new donor is A. If the new donor is A, that one is the scenario. If the new donor is A has antigen A in the surface, but this recipient A doesn't have antibodies, so there is no possible conjugation or matching or connection between these antigens with no antibodies. The same concept we apply for the other two types of blood, AB or B. In other words, if the recipient doesn't have antibodies in the plasma, and the only case we have is the group or the type AB. If this blood type doesn't have antibodies, can receive blood from any of the other types, including itself. So AB can receive blood from donor O, A, AB, or B. And this one is the condition that makes AB universal recipient. Now, with the same concept, I invite you to play with different kind of recipients and different kind of donors. In the next video, I'm going to play with other different scenarios. And pay attention that in this video, I didn't include a third antigen possible found on the erythrocytes surface. That is the antigen D. But this one is part of the following video. So far is the concept I want you to know and to learn. And we'll continue in the next video.